Welcome to the Rosny College series of electronics videos. In this video I'll be looking at how to calculate series and parallel resistances, or their equivalents. You can see from this diagram we've got two resistors in series, and I'm suggesting that it's equivalent to a single resistor with some value. For series resistance, we simply R1 plus R2, we just add them together. So if there are only two resistors, in this case R1 plus R2, if there were three it'd be R1 plus R2 plus R3, and so on. So in this circuit I've got a 5k plus a 1k, so RT is my total equivalent resistance, that's how we usually denote it, is equal to R1 plus R2, which is equal to 5k plus 1k, which is a 6k resistor. Another example, this one a little bit more tricky because I'm dealing in one in k and one in ohms. So best way to deal with this is to convert everything to ohms, or the lower of the two. So again, RT equals R1 plus R2, which is equal to 820 plus 2.2k, which is equal to 820 plus 2200. Okay, add the two together, I'm going to get 3020. 3020 ohms as my equivalent total resistance. Another example. If I have two resistors, then I want to have them in series to give an equivalent 3k resistor. One I have a 2.2k and an unknown value. Which value do I need? So again, RT equals R1 plus R2. However, in this case we know RT, so we're saying 3k equals R1, 2.2k plus some unknown value. Subtracting 2.2k from both sides, I get 3 minus 2.2 equal to R2, which is 0.8k, which 0.8k is the same as 800, so R2 equals 800 ohms. Another example of those, if I have three resistors in series and equivalent to a 16k resistor, so R1 or RT is equal to R1 plus R2 plus R3 in this circuit. So we know the equivalent resistance is 16k, R1 is 2.2k plus, don't know R2, plus 12k. So 16k is equal to, and I'm going to add the numbers I know, so 12 plus 2.2 is 14.2k plus some unknown resistance. I'm going to subtract 14.2 from both sides. 16 minus 14.2 is 1.8 equals 2. Now looking at some parallel resistance circuits. In this circuit I've got two resistors in parallel, they're both 10k, and I'm suggesting that it's equivalent to a single resistor of an unknown resistance. We can calculate that. Intuitively I could look at these and say, okay, I've got two resistors that are identical in value in parallel, so that the equivalent resistance will be half of that resistance, because electrons can go either way. It's got two paths to choose from, so twice as many electrons can get through, which offers half of that opposition to electron flow. However, let's use the parallel resistance formula to calculate this. So the parallel resistance formula is often seen in a number of ways. So we could say that 1 over RT being the equivalent again, is equal to the sum of the inverse or the reciprocals of each of the resistors. So in this case I've got 2, R1 and R2. So if I take the sum of the reciprocals of those, that's equal to the reciprocal of my equivalent resistance. A better way of writing this is, so this is equivalent to saying RT is equal to, that's the reciprocal, minus 1 is the reciprocal of R1 plus the reciprocal of R2. Now the reciprocal of something is simply, you can do the reciprocal twice and end up with the same thing. So if I took the reciprocal of RT, I get RT. So RT is equal to R1 to the power of minus 1 plus R2 to the power of minus 1 to the minus 1. So if I took the reciprocal of the sum of the reciprocals, I end up with the equivalent resistance. This is the formula I prefer, and this is the formula I'll prefer you to use, because it's more simple to use. And I'll show you how to use the calculator to do that in a very easy way. So let's find this equivalent resistance with our two 10k resistors. So RT is equal to, so I'll do the bracket, and I've got 10k minus 1 plus 10k minus 1, all to the power of minus 1. Take my resistor. Now I need to do the bracket. Now it's working in k, so I just go 10. If I do the inverse, or the reciprocal, which on this calculator is different for different ones, there it is. So it's the whole button to do it. X to the minus 1. There's my reciprocal button there, so fast. Close the bracket and reciprocal again. And if I press equals, I get 5, which is what my intuition told me. So it equals 5k. Remember before I was saying that if I have two parallel resistors that are equal in value, then the equivalent resistance is half of one of those resistors. So in this case, 5k. Let's do another one for good measure. This one will be a little bit more difficult because they're not equal resistors. In this case I've got a 12k and a 2.2k, and there's some equivalent resistance that's equal to those two resistors in parallel. So, RT is equal to bracket R1 reciprocal plus R2 reciprocal, and take the reciprocal of that. So I'm just going to work in K for this one. So I've got 12k plus 2.2k brackets so if I do my 12k, I'm just going to work in K. Now notice how I'm getting a very small number there, 0.537 something. That's because I have forgotten to do the final reciprocal. So I haven't done the brackets in this case, like I did before. So I've just done the 12k, the reciprocal of 12 plus the reciprocal of 2.2, added them together, and I get a very small number. So that's not my resistance. 0.537 ohms is not my resistance. I need to take the reciprocal again, and I get 1.8. I'm going to round it to the nearest tens of ohms, so 1. Actually, I'm going to the two significant figures. 1.90k, that is. It was 1.9k. final example. Only this one a little bit more difficult because we are trying to get an equivalent resistance with two resistors, one of which is unknown. So again, okay, this one's probably easy to go back to the original form, which is this one. Because then what I can do to isolate R1, R1 is the unknown, I can subtract R2 reciprocal from this one. So R1 RT reciprocal minus R2 reciprocal. And to get rid of that reciprocal, which I can do now, I'll just put a bracket around it, take reciprocal. Okay, so it looks very similar to my equation from before, except I've got to subtract now from my total equivalence reciprocal. So R1 equals, I'm just going to work in K here, minus 18 so I've got 10 reciprocal minus 18 reciprocal, and I'll take the reciprocal again and I get 22.5k. So R1 plus 22. And it's important to remember that if you work in K, you need to have all of your values in K. Otherwise you need to convert to one or the other. So I could work in thousands of ohms here, so I can go 10,000 reciprocal minus 18,000 reciprocal, take reciprocal of that, and I'll get 22,500 as my result. Let's just check to make sure that that works. 10,000 reciprocal minus 18,000 reciprocal equals, take reciprocal, 22,500. Good. Still another problem similar to that one. So we have a 3k equivalent resistance from a 4.7k and some unknown resistor. So if I have, I'm going to use the same formula, so R1 is equal to RT reciprocal minus R2 reciprocal. So again, working in K, I've got 3 reciprocal minus 4.7 reciprocal equals, take the reciprocal and convert to decimal, 8.3k. So R1 equals 8.3k. And finally, when we have more than two resistors in parallel, you don't really change things too much from the original equation. So if I've got RT is equal to, so the reciprocal of RT is equal to the sum of all the reciprocal of the component resistance. So R1 reciprocal plus R2 reciprocal plus R3 reciprocal. So in order to get RT, I can take the reciprocal of that again. So I must do the same for this side. So the formula doesn't look all that different, it's just got the extra R3 term in there. So working in K once again, 2.2 minus 1 plus 1 plus 3. So 2.2 reciprocal plus 1 reciprocal plus 3 reciprocal equals, take the reciprocal and convert to decimal, 0.56. So RT equals 0.56k. which is equal to 560 ohms.